Our next keynote presentation is sponsored by the United Soybean Board. It's titled Collaboratively Delivering Soybean Best Management Practices. Collaboration has been the key to amplifying resources and delivering soybean best management practices in North Carolina and nationally. In this presentation, several examples of effective collaboration resulting in delivery of best management practices will be highlighted. The first will discuss the updated generation of planting best management practices that has resulted from a strong relationship between North Carolina State University and their state Soybean Producers Association. The next example will highlight a multidisciplinary cover crop project to help deliver short-term agronomic and pest suppressive benefits for soybean production in North Carolina as a result of cover crop use. The final example will center on USB-funded Science for Success project, which brings together soybean extension personnel from across the country who collaboratively deliver best management practices to soybean farmers through common research protocol execution across the U.S. and effective summary of previous QSSB-supported research. Best management practices of investigation that will be highlighted have included foliar fertilizers, sulfur fertilization, nitrogen fixation under various fertility regimes, and biological seed treatments. All examples are linked by effective collaboration providing robust best management practices to soybean farmers. Presenting our next keynote is Dr. Rachel Vann, providing leadership for the North Carolina State Soybean Extension program focused on providing soybean stakeholders across the state with agronomic information that will aid in maximizing North Carolina's soybean yields. Additionally, she serves as the state's Plant Sciences Initiative Platform Director for Extension, Outreach, and Engagement, and the lead PI for the National USB-supported Science for Success project. She is a local. Rachel grew up in Geneseo and received her undergraduate from right across the road here at U of I, Urbana-Champaign. Please help me welcome Dr. Rachel Vann.
All right, well, good morning, everyone. I am delighted to be here, and as was already articulated, I'm especially excited to be here because I grew up in Geneseo, Illinois. Then I went to the University of Illinois for my undergraduate degree. I'm very proud to be an alumni of the College of ACEs, and I had a lot of foundational research experience and a strong academic foundation leaving Illinois to go on to NC State, where I did my graduate work and now serve as the soybean extension specialist. So when I was invited to do this presentation, I was excited, but I was also thinking, you know, as a soybean specialist in North Carolina, what can I come up here and offer to soybean growers in Illinois? And working with the Illinois soybean staff, we kind of landed on some collaborative projects that I think have catalyzed our ability to deliver best management practices to our growers, both in North Carolina, but at the national level as well. And the reason I'm not going to emphasize much about our production practices in North Carolina is because they're quite different than what you have here in Illinois. I'll give one slide to sort of articulate that. So for those of you who don't know much about North Carolina production, we are actually the third most agriculturally diverse state in the U.S., behind California and Florida. We are the #1 U.S. producer of flue-cured tobacco and sweet potatoes. So those are very big crops for our state. We also are a top 10 producer of a variety of vegetables and fruit crops. And we are a very large animal producing state. We're actually the #2 consuming state of U.S. soybean meal. We have a lot of hog and a lot of poultry production in the state. We can only feed our livestock for about 50% of the year on the grains that we produce in North Carolina, and the rest is getting railed in from the Midwest to feed our very robust livestock industries. So that diversity leads to quite a diverse set of production practices used for soybeans in North Carolina. We kind of have 3 distinct production regions in the state. Out near the coast, we have organic soils that have 5 to 15% organic matter. We call them the black lands. Although I will say Fred Belo came down and talked to our growers 5 or 6 years ago and told them that y'all would laugh if you came down there and saw those soil types, and we were calling them the black lands, but I'm sure you can imagine that went over well with our growers. But we have these diverse production regions, very diverse rotations, and what that results in is we have growers in the state that plant from late March through late July. So we have growers that are planting behind wheat. About 20 to 30% of our acres are double crop. And we also have growers that plant behind corn in the same season, soybeans, or behind snap beans. So a very wide range in planting dates. We produce a very wide range of maturity groups 2 through 8. I didn't make a mistake there, 2 through 8. Very wide range of maturity groups. But we do have a very strong demand. So I just wanted to give you a little bit of flavor of North Carolina production, why I'm not going to really emphasize the best management practices that we have in the state specifically, because our production situations are very different, but rather focus on some collaborative efforts that I hope will incentivize you to think about how you metabolize information or how you might fund future research projects. And because this is a football-themed conference, I just had to emphasize that we are the Wolf Pack, in case you didn't know, NC State, but I'm also a fan of the Illini and follow along when I can. So I'm going to provide 4 examples. I didn't have my abstract comprehensively updated, but kind of 4 collaborative examples to win the Collaboration Super Bowl. So the first is we have a very close relationship between NC State University and the NC Soybean Producers Association in North Carolina, and that's really allowed us to deliver best management practices to our growers. They don't just fund research trials at the university. There's a lot of bilateral communication about how to drive projects forward to provide the most benefit. I'm also going to give an example of a project that we have collaborating across agricultural disciplines, which has allowed us to deliver the most holistic recommendations to our growers about cover crop implementation. I'm going to highlight our National Science for Success project briefly, but also encourage you to come to the Breakout Blitz section that will be focused specifically on our National Science for Success project. And then finally, I'll end highlighting a collaborative project that we have across NC State University where we're really trying to leverage broad talent to work on agricultural issues. So the first example is some of the things that we've been able to achieve through close collaboration with the NC Soybean Producers Association. And I just recently learned in their newsletter that the NC Soybean Producers Association was actually the first state checkoff organization in the United States for soybeans, which I thought was an interesting fact. And again, we work closely with them at NC State. And one of the things that we do is we co-sponsor a yield contest annually to recognize our high-yielding producers and also understand the production practices that have the most influence on high yield in our environment. So when our growers enter the yield contest, we require that they also provide a bunch of different production practice recommendations that are associated with those high yields. And we collaboratively manage this yield contest. And what we had was this big database of information with all these yields and all these production practices that was just sitting there being untapped. So when I got into this position several years ago, I started working with my colleague at the time, Catherine Stowe, on a project to actually look at almost 900 yield contest entries over an 18-year period in our environment to identify the strongest predictors of high yield. We wanted to describe the production practices associated with well-managed beans in North Carolina, understand how those have changed over time, and then identify more broadly management strategies that could be implemented on our wider acres to increase soybean yield. So when we looked at those almost 900 entries for our environment in North Carolina, we identified 3 strong predictors of high yield. The first was maturity group, with maturity group 4 earlier averaging 73 bushels per acre and the later maturing varieties averaging 55 bushels per acre. The next thing we identified was that foliar fungicide use in our environment was a strong predictor of high yield, regardless of the maturity group being used. You know, we're at a lower latitude, we have different disease complexes. And then finally, there was some advantages to early planting before mid-May, even before late April, in some of our high-yielding situations. So to recap from that analysis, the 3 strongest predictors of high yield was using earlier planting dates, using foliar fungicides, and using earlier maturing varieties. And there are some practical limitations of implementing those on our broader acres. And here's a QR code for a whole chapter that's written our production guide about this. But I wanted to show this example because what we did here was collaborate with the NC Soybean Producers Association. This is not a funded project. It was just something sitting there that we could take advantage of to provide value to our farmers. And not only did it have, you know, educational value, but it also helped drive a lot of our small plot research program forward. So speaking of small plot research, one of the things that we've been working on in North Carolina over the past few years is trying to optimize our production practices across the diverse planting dates that we use. As I mentioned, we have growers planting from late March all the way into late July. There's a wide range of maturity groups, seeding rates that should be used across those planting dates. And we've been working on a small plot study trying to provide those recommendations. Ultimately, we're trying to build out a simple tool where growers can go plug in their planting date. It'll generate a prediction on the best maturity group and seeding rate to use across our different regions. And this was going to be a very yield-focused study. Also, we were also looking at damage. Our growers can run into some issues at the elevator when we're harvesting early maturing varieties in August and September. High temps, heavy rainfall, we can see phomopsis, purple seed stain, other issues. But one of the things just in the middle of this trial that came about through our open communication channels with the NC Soybean Producers Association was the value of actually collecting other quality parameters like protein and oil and how these production practices affect that aspect of quality. And so we were able to collect information on that in this trial as well, which has now been conducted across many environments in North Carolina. And here's a QR code for the first publication that came out of this research if you're interested. But so the real goal was to develop this tool that growers could use to predict the optimal production practices. But another thing that came out of this study was actually the ability to move the early replant coverage date for RMA earlier for North Carolina soybeans, which is something that happened through these collaborative efforts between the NC Soybean Producers Association and NC State to try to get this done. This is some of the data that went into that. On the x-axis here, we have planting date. On the y-axis, we have yield. If you look at our environment, the planting date that maximized yield across all these research sites was May 1. As you would expect, we see yield declines when we push out into double crop situations. We can also see yield declines from early planting in North Carolina, which I won't describe in detail, and you can ask me about it later if you're curious. But what this data was able to do was help get our early replant coverage date moved earlier in the calendar year in North Carolina, which was a big priority of our growers. If you look at this map, which was developed by our Science for Success team, these are now the early replant coverage dates for beans across the United States for 2023. And in North Carolina, our early replant coverage date is now April 1st, when before in most of the state it was April 21st. So working closely with the NC Soybean Producers Association allowed us to get this done. So I would say the collaborative touchdown here was that by working closely, not just them funding our research, but very intentional bilateral communication frequently, it accelerated our ability to deliver solutions for North Carolina soybean farmers. The next example I will give here was about collaborating across agricultural disciplines. So as many of you are familiar, the United Soybean Board, the U.S. Corn Growers Association, the U.S. Pork Council have set this goal that we are going to have 30 million acres of cover crops by 2030. Which is a considerable increase beyond what we currently have. And in North Carolina, I'm very passionate if our growers are going to be increasing cover crop acres, that we are optimizing short-term benefits in addition to some of the longer-term benefits that were articulated in the previous presentation. but we're using cover crops and selecting species and managing to do things like suppress weeds in our following soybean crop, suppress nematodes in the following soybean crop, conserve moisture in the following soybean crop. And to do that, we have to have the right species, we have to have the right varieties within individual species of cover crops, and we have to have the right management strategies. So for us, the agronomists in the state, we've often said, okay, we've got to get as much biomass as possible to optimize these short-term benefits like weed suppression or soil moisture conservation. This is actually a picture of organic beans in North Carolina. No herbicides applied on these, and this cover crop mulch has suppressed weeds throughout the season. We are at a major advantage in North Carolina. We can get a lot of cover crop biomass from cereal rye. I'm talking like 6-7 feet tall, and we're not having to push super hard to get those levels of biomass. So we can do this, and we've always said, you need to terminate your cover crop as soon in close proximity as possible to soybean planting to maximize biomass. So we can optimize weed suppression or soil moisture conservation in your following soybean crop. But what that does when you're terminating your cover crop in very close proximity to soybean planting can cause other types of issues. One of them in our environment has been from three-cornered alfalfa hopper. I'm not sure if that's a pest that you have a lot of challenges with up here, but our growers have run into challenges when they're terminating their cover crop right at soybean planting. There's been three-cornered alfalfa hopper in the cover crop mulch, which has caused issues with stand later in the season. You're getting into reproductive development. The three-cornered alfalfa hopper causes issues at the base of the stems, plants snap off. So the entomologists want to recommend that you burn your cover crop down 3 to 4 weeks in advance of planting in North Carolina to try to minimize the insect issues. And so our recommendations have not always been aligned or well thought out. And so I'm excited about a project that we recently did. We are blessed in North Carolina to have extension specialists that cover many production areas and many different crops. And so instead of us all doing our cover crop research in different silos, we really worked together as entomologists, nematologists, plant pathologists, weed scientists, agronomists to deliver the most holistic cover crop recommendations that we could. And one of the things we learned in this trial is interesting, and I wanted to highlight, this is specific for our environment, but I think shows why collaboration is important. The red bars here are where we terminated the cover crops 4 weeks before planting. So that, for us, that would be for full season beans, let's say first week of April. The green bars are where we terminated the cover crop at planting. Biomass is on the y-axis. And one of the interesting things we learned in this study, there was a lot, this is just one example, was that only 3 of the 8 sites did we actually reduce cover crop biomass by terminating it 4 weeks before planting. That's counterintuitive to what we thought or what we've been recommending as agronomists to optimize some of these short-term benefits. So what that allows us to do is, okay, rethink what are our recommendations. And now we're like, yeah, you can terminate your cover crop several weeks prior to planting. In some circumstances, you won't be compromising biomass, and you'll be minimizing some of the insect issues you might run into. This is a grower, Gary Hendricks in North Carolina. He's actually the president of the NC Soybean Producers Association now. Great farmer if you have the opportunity to interact with him at the national level. You can see he's modified his planter to be able to plant through these heavy cover crops. And we're excited about how collaborating more effectively across disciplines can give recommendations to farmers like Gary on how to maximize the short-term benefits of cover crops, minimize the impact on the following soybean crop. So the collaborative touchdown here is we were able to deliver more holistic recommendations on cover crop management by working together across disciplines. The next example I'll highlight is from our National Science for Success project, where we're collaborating across the United States. And this is a United Soybean Board supported project that brings together extension specialists from all across the U.S. to collaboratively deliver best management practices. And I do want to give a shout out for the University of Illinois because Emerson Nafziger has been a part of our group for the past 4 or 5 years. I'd say he's a good mentor, kind of keeps us in line on some things. And we're also delighted that Dr. Giovanni Prezafantes, who you'll hear from later today, is also a part of our group. And we had a Science for Success meeting in Minneapolis like 3 days after Giovanni started, and he was there at the Science for Success meeting. So I'm like, yeah, he's got his priorities straight, collaborating with Science for Success. So again, this group supported by the United Soybean Board, our goal is to deliver these best management practices. And how do we do that? We summarize existing and ongoing state-level supported checkoff research. So each of us within our individual states are doing different research projects. You just heard about some in the previous presentation. But we've not always coordinated those efforts or been comprehensively knowledgeable about what was going on within each state. So there might be a lot of overlap or a lot of opportunities for collaboration that were missed. So one of the things this group does is really just focus on trying to summarize existing and ongoing state-level supported soybean checkoff research. We also collaborate on national research trials to drive these best management practices, and every year those change. This past year we were looking at N-fixation under different fertility regimes, or biological seed treatment trial, which was led by my colleague Dr. Laura Lindsay, who will also be on the Science for Success panel in a bit. But each year these trials change the topics of focus. And ultimately, this is an outreach project supported by the United Soybean Board. The research is funded at the state level. And in this outreach project, we're trying to amplify our state level research and extension knowledge into national extension impact. So I'll give one example. You can get more details in the Breakout Blitz 1 session, but in 2019 and 2020, our group looked at the value of foliar fertilizers applied prophylactically, so without any visual nutrient deficiency symptoms at R3 or beginning pod, in research all across the United States. And so we did this research in 46 sites across the U.S. in 2 years. You're able to capture a lot of environmental variability. You're able to capture a lot of different yield environments in a short period of time, which is the beauty of doing this research across the United States. And so in this work, we were able to identify best management practices related to foliar fertilizer applications at the R3 or beginning pod growth stage. That information is available at this QR code. And I will emphasize we collaborate closely with the Soybean Research and Information Network website, who houses all our information. And there's some more information available on Shrin in the room next to us. But that's just an example of the collaborative research we're doing and how it can drive best management practices. So come learn more today about Science for Success at the Breakout Blitz 1 session. We'll have a panel with Dr. Laura Lindsay, Dr. Giovanni Prezafantes, the new grain specialist at the University of Illinois, and myself, and we'll go into more detail about some of the things Science for Success is doing. But our collaborative touchdown with Science for Success is it's catalyzing our ability to deliver recommendations by allowing us to rapidly capture different yield environments, different environmental conditions to drive best management practices. It's also just a better way to amplify checkoff resources by collaborating together and minimizing overlap. And the final example I want to give today about collaboration is an initiative that we have at NC State, which is really centered on collaborating across the whole university. And this is called the NC Plant Sciences Initiative. And our goal with the NC Plant Sciences Initiative is to leverage every ounce of talent across NC State to work on agricultural issues. You know, in the past, it's often been scientists in the College of Ag and Life Sciences that were, or the College of Agriculture, ag engineers, ag and human services expertise that were focusing on the agricultural issues. But in this initiative, we're trying to get everybody at NC State to work on agricultural issues. So if you look at this figure, the red dots are for individuals in the College of Ag and Life Sciences. The blue dots are individuals in the College of Engineering, not ag engineering, the College of Engineering. So now we have scientists from nuclear engineering, computer engineering, chemical engineering, who normally work on other aspects of society, working on agricultural issues, because we know we have grand challenges that need to be addressed, and we need to get talented people that have different viewpoints and different expertise involved to help address these issues. We also have individuals from the College of Education, College of Sciences. We have a College of Textiles at NC State, all at the table working on these agricultural issues. And we see some real assets that we have in North Carolina, but that you also have in Illinois as very close relationships with agribusiness. We have a research triangle park in North Carolina, which has a lot of ag innovation companies headquartered there. We also have NC State Extension as a key piece of this puzzle to help both drive projects that have practical implications for growers and also help disseminate the gleaned information. Now, I will say a big catalyst in bringing these groups together was this Plant Sciences building, which was a $160 million fundraising initiative by the university that has some special assets that scientists from across the university are interested in leveraging. And there were some big fundraising efforts for this. I think one of the most unique aspects of this initiative, though, was that it was our commodity boards in the state that were the first funders of the Plant Sciences Initiative, because they believed we needed to be bringing in new talent to address their challenges. So the commodity boards gave the initial funding, and then there was a lot more funding that came in along the way. But they believed in the mission of the Plant Sciences Initiative to start leveraging new talent. So this is a big initiative. We've got different research areas, one focused in the plant improvement space, things like using 3D printing to improve genetics. We have another one focused in the resilient agricultural system space. The data-driven space is a big aspect of this initiative. How are we going to leverage large data? How are we going to have the servers to handle that amount of large data? And then there's platforms that are focused specifically on how do we educate the next round of workforce to work on these agricultural issues, and how do we effectively disseminate information to growers. And you got different platform directors. I'm the platform director for Extension Outreach and Engagement, which is why I'm so familiar with what this initiative is doing. But the interconnectivity of these platforms is what really makes this initiative unique. I'm going to give a couple examples of things that we've been doing. One was this Backroads tour, where we got faculty all across NC State to come out to the field and engage with our farmers. And these are people, some of them that have never been on a farm before. There was an engineer out there who's an expert in robotics and automation that can are going to have impacts on the agricultural space that was out there. These growers were picking cotton. She's like, taking pictures in front of that cotton picker. I'm like, girl, you're going to have to get out of the way. That cotton picker will run you over if you just stand there and are taking these pictures. But we're getting new people out into the field to get ideas about how we can address these ag issues and do relevant projects moving forward. Another example I'll give you is a project that's led by a nuclear engineer as part of this initiative. She is an expert in plasma, and usually works on plasma to heal human wounds. That's her expertise. But there was a funding opportunity as part of this initiative that got her interested in working on agriculture. So now this nuclear engineer, who's an expert in plasma and usually looks at plasma to heal human wounds, is actually looking at the possibility of plasma as a mechanism to generate fertilizer on farm. So looking at an agricultural issue, this is someone who would previously have not been working on agricultural issues. So that's kind of what this initiative is all about, bringing new types of talent together to deliver solutions to our farmers. And there's a lot of successes already that have been associated with this young initiative. But I would say, some of our key successes are that we've been very intentional about including farmers and applied expertise from project conception all the way through execution. It's really the farmers that are driving the projects. And that's why, for example, some of our core projects have been things like automating the sweet potato packing line industry. A lot of that before with sweet potatoes, they're harvested by hand, they're dug and harvested by hand, then they go down a packing line. It's all human eye deciding the quality of the sweet potatoes and whether they're going into the grade 1 or grade 2 markets. Now, a project through the Plant Sciences Initiative brought engineers who never worked on agriculture before to deliver solutions to allow for automated visually of these sweet potatoes coming down the packing lines, and so it's being done by automation instead of the human eye. That's just one example of the power of this type of collaboration across many disciplines. So I think the collaborative touchdown here is leveraging all the available talent to help address our agricultural issues. So in conclusion, to win the collaborative Super Bowl, I think it's important that the universities and the checkoff organizations in the space are working closely together to make sure that the funded projects have the most impact possible on the farmers. I think collaborating across the agricultural disciplines is critical to deliver more holistic recommendations. I'm very excited about our Science for Success project that's delivering best management practices on the national level on a variety of topics, as well as sort of envisioning how in the future we can bring in more diverse expertise to work on agricultural issues and how that will be critical to deliver more innovative solutions. So I would again want to articulate, I'm so delighted to be here, very thankful to the Illinois Soybean Producers Association staff and growers who invited me to be here today. And I intentionally, didn't make this the whole time period because I was hoping there would be some questions and discussion on this topic.
Thank you. We do need, just as a reminder, so we're recording, we're Zooming, so please do use the microphones, especially for the audio for those who aren't here. First question.
Were you involved in any of the foliar fertilization studies on soybeans that you mentioned briefly?
Was I involved in those?
Yeah, and could you elaborate on them if you do?
Yeah, absolutely. So I think we had 16 states involved in that trial, and I was one of the PIs on that. We had 5 or 6 sites in North Carolina. And what we found in that trial was we looked at a variety of the most nationally relevant products. There's no way we can comprehensively evaluate all the foliar fertilizers that are available to you. But when we ran these trials all across the U.S., putting out these products at R3 when there was no other visual nutrient deficiency symptoms, we found that there was no impact of the products on soybean yield. And if you calculated out, the cost of these products, that could save soybean farmers $4 to $22 an acre. And we looked at applying those at R3, beginning pod. There's, we got a lot of criticism about the study. You should have looked at it at different timings, earlier timings, different products. Well, we chose the most nationally relevant products and looked at them at R3 because a lot of growers are making a fungicide and insecticide application at that timing. And across many U.S. sites and many yield environments saw no impact on soybean yield.
We have a couple questions from our virtual attendees over here.
Great.
So the first one is from a Northern Illinois participant, and a problem they're having at harvest is that the grain moistures are dry, but green stems and life is left in the plant, leading to delay harvest. Do you have any best management practices that could help with this?
Yeah, that's a fantastic question and one that we get from our growers often. I honestly didn't know it was an issue that y'all encountered as frequently in the Midwest. So definitely in the Mid-South, like Arkansas, Mississippi, Louisiana, and North Carolina, where we're starting to produce these earlier maturing varieties, we can see a lot of issues with green stem, which is where the pods on the plant are ready to harvest, the stems remain green, and we don't have a very robust understanding of what causes this, but generally it's associated with you've got more genetic capacity in the plant than you have pods. So you have too much plant energy, there's not enough sink, not enough pods for that plant energy to go into, so the stems remain green. And are there best management practices for this? I would say in our experience, largely no. There's a few things you can do in our environment. Stink bugs can cause green stem, so we recommend that our growers scout through R7 for stink bugs to try to minimize the issue. We get a lot of questions about desiccation, so using harvest aids to minimize green stem. And I think from what we've seen in the field, if you get the desiccant on at the right time, so R6.5, when the bean's just separating, the bean is fully separated from the membrane that connects it to the pod, that's when you're at R6.5. If you put a desiccant on right there and you've got foliage on the plant, that can help resolve some of the green stem issues. But a lot of the questions that we get are like, you're at R7, there's minimal leaf material. Can you put a desiccant on to minimize green stem at that point? And the answer is largely no. So I think in terms of best management practices, you have to be scouting your beans for insects, trying to minimize stressors, because some limitation of pod and seed development is a contributor to green stem. But I wouldn't say we have a lot of robust best management practices. In many situations, when that happens for our farmers, they have to harvest slow and just get the beans out of the field. Otherwise, we see some big seed quality degradation issues. I'm talking like 20-30% damage if you leave them in the field too long.
Before you ask the next question, how many farmers deal with that? Or just what I hear is they say that soybeans are cutting tough. I mean, I would imagine that's close to everybody, isn't it? And you can't get in until noon anyway, or later. So it just shrinks that window, around harvest time. I figured all the hands would go up. But
yeah, I know. I thought it was something that was definitely intensified in our environments because we don't have the cooler conditions sort of accelerating harvest. But it's interesting to know it's a problem across this U.S. And one of the projects that we actually have some grants submitted for Science for Success is looking at harvest timing and looking at desiccation and best management practices across the U.S. So hopefully, if that's funded, we have it some proposals submitted to multiple entities. We'll be able to more robustly answer that question in a couple years.
Thank you. Our next question is that yield data in Illinois still tends to show that later maturity soybeans show higher yields. Can you explain your thoughts on why your predictors of higher yield shows that using earlier maturity soybeans may be better?
Yeah, that's one thing I want to emphasize is, and there's other parts of the Midwest where they see optimal yields with the later maturing varieties. Now, I will say in general, you're working with a much narrower maturity group range than we are in North Carolina. And I think one of the reasons that we see earlier maturing varieties maximizing yield in high yielding situations is because they're superior genetics that do well in high productivity situations. So if you look at genetic gain in soybeans across the different maturity groups, the genetic gain, so the progress breeders are making annually, is higher in an earlier maturing variety than a later maturing variety. And it's even higher in high yielding situations due to enhanced branch capacity, enhanced ability to put pods on branches. So in our high yielding situations, I think the superior genetic gain allows earlier maturing varieties to maximize yield in our high yielding situations. On our average acres, a maturity group 5 or 6 will out yield an early maturing variety. It has to be in a high yield situation.
other questions? Right here. While you're coming up here, let me ask a question also. What have been advantages of bringing in people from across campus or from outside the School of Ag? Like, did you expect some roadblocks, or we're all professionals here? What has been some of the benefits of, or did it take a bunch of time just to understand terminology and all that, or were there learning curves, or did that go better than you thought it was going to go?
Yeah, so that's an interesting question, and I will say there are great joys and there are also great challenges as you start bringing people in to work on agricultural issues that have no idea about how things function in the field. It takes a lot of time for applied researchers to try to explain the on-farm issues and get these researchers out onto the farm to see how their technologies and their expertise can contribute. And I think that's been a challenge. But also these individuals are very open to working on agricultural issues. And I think one of the most exciting things to me is if you think about the people that are knowledgeable about agriculture in society, it's often been the people that work directly with agriculture. But now we're bringing in engineers and people in the College of Education and textile people who previously didn't work in agriculture, who now know how exciting it is to work with farmers and how hard farmers are to working to deliver sustainable food and fiber to U.S. citizens and beyond. And I think having these like additional agricultural champions out in society who didn't know about agriculture before is one of the best aspects of working across these disciplines. Yes, there's challenges and there's also joy. I think they are bringing a unique lens into how we can deliver some of our agricultural solutions, things that applied researchers have never even thought about.
I would like for you to elaborate a little bit more on the question of planting soybeans, what we call green, then terminating, and you indicated that you had what I call bug problems, versus terminating about 3 weeks earlier with respect to the yield of the soybeans.
Yeah, that's a great question. So one of the big challenges that we have in the Southeast and the Mid-South with these dynamics of planting our cash crops in close proximity of when we're terminating our cover crops is the soil moisture dynamic issue. So when you're not killing your cover crop until you're planting your beans, in our environment where we're often lacking moisture, which I know is different than here, you can run into soil moisture issues early in the season, the beans not having enough soil moisture. That can sometimes cause a yield drag for us. Also, there's years where it's too wet and having your cover crop growing right before you plant is actually an advantage. So it's very dependent for us on soil moisture dynamics at planting and how that influences when these cover crops are terminated. We have seen insect issues. We have big issues in some circumstances with slugs behind our cover crop mixes, and earlier termination has in some circumstances helped us minimize those issues. We can also see things like the three-cornered alfalfa hopper. And what we've been really emphasizing in North Carolina is if you want to try to terminate your cover crop in close proximity to soybean planting because you're trying to change the moisture dynamics or optimize other benefits, you can do that, but you better change your scouting regime for insects early in the season. And we're generally not a state that's scouting soybeans early in the season. Our growers are busy with other crops at that time, but if you're going to terminate green, we've found that more intense early season insect management down in the cover crop residue is critical.
I have one more over here. This is about early planting dates. So can you share more on the importance of planting dates and what yield benefits there may be to planting earlier?
Thank you for the question. There's been a lot of energy all across the United States about planting soybeans earlier. And generally the thinking is the earlier you plant, the more nodes you have, the more vegetative biomass you have to drive photosynthesis. And there's been a lot of talk all over the United States about that. The big NCSRP Boots on the Ground project, which I'm sure y'all have some level of familiarity with, focus a lot on early planting, and many of our colleagues have addressed that issue across the U.S. In our particular environment, we found the optimal planting period for most production situations in our state is about April 25th to May 10th. But with our rotational complexity, we had a lot of growers that weren't planting even their full season beans until the beginning of June. They were busy at the beginning of the season with tobacco, sweet potatoes, cotton, peanuts. Beans went on the back burner. But now with the high price of beans and our growers really focusing more on beans as a priority in the rotation, this early planting has been a big emphasis for us. And actually of the row crops we produce, beans are the most resilient planted into cold conditions. So now a lot of those growers that would wait to plant their beans until late June are actually planting their beans before they get started with anything else, maybe middle of April. And we've realized some large yield advantages in North Carolina from that. And I know earlier planting has been emphasized across the U.S. as a mechanism to increase soybean yield.
Well, questions over here.
Did you see a favorable cover crop termination method out of your research?
Yeah, it's a good question. Did you see a favorable cover crop termination method? I actually did my graduate work in organic grains several years ago, so I have quite a bit of familiarity with the roller crimper versus burning the cover crops down with a herbicide. But in our research now, I work with large conventional soybean growers in North Carolina. We've just looked at terminating with a herbicide, and that's what most of our growers do. It's worked effectively. We do have some growers that have fabricated rollers and are using that, but the majority of our growers are just terminating with herbicide burn down, and it's working well. Now, when you start getting into some of these mixes, like you got rapeseed in there, we've had some issues in the past. We got some Roundup resistant rapeseed in there. I mean, there can be some challenges with herbicide burn down, but for the majority of our soybean growers who are going to run often just a monoculture small grain in front of soybeans, herbicide burn down works fine.
Just real quick question or comment. Thank you for mentioning the NCSRP project on planting date. Certainly that multidisciplinary, multi-state team has spent and will continue to spend time. One of the things that NCSRP is talking about, researchers and staff and farmers are talking about, as well as many of the QSSBs in the Midwest, is should we be calling these research efforts early planting date studies, or should we be calling them optimized planting date studies? Because as you know, and everyone here knows, we have so many different variables. You mentioned soil moisture. We have extreme weather events. We have all these different soil types and other parameters across the Midwest to consider when we consider what is the optimized planting date for soybean. How do we better manage soybean, much like we're managing corn for many years? I'd be curious what your thoughts are on that, tweaking that title from early planting date to just optimized planting date for soy.
Yeah, I think that's a great comment, Ed, and I totally agree with you. If you looked at that data from that graph I showed here, in some of our environments, there's a yield drag from early planting. It's a very complex situation. That's why in North Carolina, we're moving towards this grower decision support tool that will predict the best planting date based on your region and drives down into more precision recommendations about planting date rather just saying, you should plant early. I've heard Emerson talk about this before, and it's something we see in North Carolina. If you plant too early in a lot of our soil types, you'll actually get less vegetative biomass early in the season than if you plant a few weeks later. And I think that has to do with temperatures and how they drive vegetative biomass early in the season. It's counterintuitive to what you think, but it's just an example of why we need more precision or optimized planting recommendations, and it's a great point. Thank you, Ed.
We have one here in the middle. Just out of curiosity, what's the rotation? If I'm planting soybeans in Carolina, how much is continuous, or what's before, what's after? Because I assume it's not just corn soybeans like it would be here.
Yeah, I could probably talk about our rotational complexity for 50 minutes because we just have a lot of crops. Very rarely are soybeans produced continuously. Cotton, peanuts, tobacco, sweet potatoes, corn, they're all in there, and small grains. So we have a lot of rotational complexity, which does buy us advantages on some things like pest management for nematodes or weed management, and also can intensify some challenges. It's definitely one of the reasons that if you look at the average yields in North Carolina, they lag considerably behind the Midwest. Some of it's soil type, some of it's rotational priority.
Do you have a special kind of cover crop mix, like cereal rye versus various other kinds of cover crops that you would recommend?
So I think in our environment in North Carolina, monoculture cereal rye is a great fit. If you want to add a brassica in there, there may be some advantages from a nematode suppressive perspective from doing that. But I think a lot of the challenges that our growers have ran into with cover crops have come when they've had too many species in the mix. And then one of them wouldn't be terminated easily with Roundup, and one of them intensified some type of pest that was a problem in beans, often with a legume in front of beans. And I think in our environment, cereal rye, which is a very high biomass producer, is a great fit in front of soybeans to optimize some short-term benefits, and also it minimizes some of the other challenges that we can run into with too many species in the mixture. Also, beans fix their own nitrogen, so any immobilization of nitrogen as the rye decomposes is less problematic. It's cheap, readily available in our environment.
This would be more focused in like the organic world. If you were to, do you have any experience getting a 2-3 week head start on anthesis, planting beans, and then rolling, 2-3 weeks later when the beans are VC-V1 to maximize weed suppression?
Yeah, it's not something that we've looked at largely in our environment because we can hit anthesis in North Carolina often first week to middle of April. So we're often at max biomass by the middle of April. And if our organic growers were planting that early, they'd be running into challenges with like early season pathogens. So we have not looked much at terminating the rye past planting because we don't need it in our environment to optimize biomass. But I will say we do have some organic soybean production in North Carolina, as you likely do here in Illinois. And some of our growers were getting $40 per bushel for organic beans this past year. And so I think there is going to be some increased interest in this area. Our biggest organic crops in North Carolina are organic tobacco, won't say anything more, and organic sweet potatoes, and they need to be rotated with beans, so we do have some organic production in the state.
The idea of a cigarette package that has a certified organic stamp is
They're healthy
hilarious.
for you,
Yeah,
y'all.
good for you. Environmentally sustainable, yeah. Anything else? All right, good to have you back. Thank you very
Appreciate the
much.
opportunity.